Hey, so we get to the third part of Young and Freedman's university physics, and that is on, and I'm the one that's dividing it up into parts. The third part I'm saying is on electromagnetism. So welcome to the sequence of videos on electromagnetism. Maybe you're in a Udemy course I'm doing. Maybe you're just watching on YouTube. Welcome to Physics Part 3, Electromagnetism. Let's dive in, shall we? So the first section of this chapter, chapter 21 in Young and Freedman's University Physics, is on electric charge. What's electric charge? I'm guessing you kind of know what electric charge is. Maybe you had a mischievous sibling that liked to shock you. My nephew had a little rotating thing as a child. You'd spin it and it would say something. And there was this one option where you'd spin it, and if it landed on it, it would say electric sockets in the wall. Aren't fun at all. Don't do it. Do not go sticking things around electric sockets. Electric charge, it's out there. It's a thing. So let's say what it is. So there are four basic kinds of forces, they say. If you've been following my series of physics videos on YouTube, you know that way back in a long time ago, in fact, it's not very good quality video. I'm actually redoing this video from the past to update the quality. But there's a video somewhere hiding in the world of YouTube on the four forces. And actually, in the late 20th century, it was discovered that three of these forces can be seen as manifestations of the same underlying force. The strong nuclear force holds protons together in the nucleus. Why would that need to happen? Well, we'll know later on in this video. The reason is because like charges repel each other. And protons, which are in the nucleus of an atom, in the center of an atom, there are a lot of protons. Well, depends on how many, different amounts of protons. And these are, we say they're positively charged. So you wouldn't expect all those positively charged particles, to all stay there. You would expect them to go, pshoo. In fact, we have things called nuclear explosions, that are basically that. But anyway, the strong nuclear force holds them together. The weak nuclear force has to do with some radioactive decay. It's something not real central to physics, but it happens. And it is actually a manifestation of the same underlying force. There is also the electromagnetic force, which is what we're talking about. Gravitational force, because it keeps us from flying off into space. Physics has not yet unified gravitation with the other three forces. Einstein, and I'm not 100% sure of this, but Einstein, I think, almost didn't see gravitation as a force. It's almost like gravitation is a curvature of space because of mass and velocity. Well, that's outside the scope of this video, but this video is on electric charge, which is a manifestation of the electromagnetic force. Electromagnetic interactions are one of the four known kinds of forces in physics. Now, let's talk a little bit about charge. We already talked a little bit at the beginning. If you take some fur and you rub it on plastic, they start to attract each other. Why is that, Ken? Well, I'm going to tell you. It's because the fur takes on a positive charge and the plastic becomes somewhat negative. Some of the electrons of the plastic go to the fur. And then if you were to take two furs, it's a twofer, and rub them on the plastic and then put the two fur next to each other, they would repel because they've both taken on a positive charge, and like charges repel. Same thing if you took two plastics that you'd just done this with, they would repel because they're both negatively charged. You do the same thing with silk on glass. If you take some silk, rub it on glass, the silk takes on a negative charge and the glass takes on a positive charge. I don't know whether I said it right before. The one that's more negative is the one that's taken the electrons. So if the silk becomes more negative, it's taken some electrons from the glass. I forget whether I said it right for the other one. You go back and decide. But the silk and the glass come to attract each other because the silk has a more negative charge and the glass has a more positive charge. But if you take two silks or two glass, they'll repel because they have like charges. So, like I said, 2 such plastic rods will repel, as will 2 such glass rods. Electric charge, ladies and gentlemen. You ever notice your hair stand up when it's dry? That's electric charge. So electric charge is what we say that the plastic, the fur, the glass, the silk has acquired. Now, aside from gravitational forces, most of the forces that we experience every day are the result of electric interactions. Believe it or not, friction, as I understand it, is a product of the electromagnetic force. So most of the forces we experience, again, you've got these nuclear things going on, very, very small, but most of the big, we are giants up here in the big world, most of the things that we do are, except for gravity, are a function of the electromagnetic force. Some basic rules, okay? We've been kind of hinting at them, not so much hinting as actually telling you, but we've been saying this over and over again. Like charges repel. Opposite charges attract, okay? Even if you don't know what charges are, well, what are they, Ken? Oh, ask God when you die. But anyway, so don't worry so much about the what is it really. Just remember that when we say this charge is like this charge, they're going to repel. But if this charge is opposite of this charge, they're going to attract. Like, opposites attract, right? Who do you want to date? Or who do you want to marry? Or who have you married? Or who have you dated? Sometimes it's the very seeds of your attraction become the seeds of your repelling. Anyway, does that work? Anyway, opposites attract. The total charges in any closed system is constant because the world is neutral, right? So if you have a box, the total charges in any closed system are going to be constant. They're going to stay the same. Not neutral, stay the same. The magnitude of the charge of an electron or proton is the basic unit of charge, which is really small. So an electron is the negatively charged particle of the atom, and we say it's negative. And the proton is the positively charged particle in the atom, and we say that it's positively charged. Okay, some basic rules. Atoms are the fundamental building blocks of the stuff that we can identify as stuff. So you can break everything down. You can take my cell phone apart. You can take me apart. You take the air apart. And if you were to put all the distinct little building blocks into buckets, you would have about, I think it's 93, somewhere in the 90s, naturally occurring elements. And these elements are the kinds of atoms. They're the Legos of life. So atoms are the fundamental building blocks of the stuff we call distinct stuff. They're made up of 3 basic particles. Although if you go down the rabbit hole of physics, there are lots of other particles like quarks and gluons and muons. Oh my. But the ones that you learn in elementary school are, you got in the nucleus, in the center, like the sun, you've got protons, which are positively charged, and neutrons, which are neutral. A neutron walks into the bar and orders a beer or a non-alcoholic beverage. And at the end, he says, okay, waiter or bartender, how much? And he says, for you, no charge. Anyway, I probably messed that up. But neutrons have no charge. Protons and neutrons are in the nucleus. Electrons are kind of swirling around. Now, we used to think of a solar system model, like Mercury, Venus, Earth, Mars, Jupiter. But actually, they're more like probability fields, but that's beyond the scope of this video. Anyway, so think of clouds. They're electron clouds surrounding the nucleus. And they're negatively charged. 3 basic particles: electrons, negative; protons, positive; neutrons, neutral. And atoms have a very small nucleus surrounded by lots of space where the electrons might be. So that's that. Well, let's wrap this thing up, shall we? Other important items to finish out this video. The number of protons tells you the kind of atom it is. That's the key thing. Electrons can come and go, but protons are the ones that tell you whether it's a carbon atom or an oxygen atom or a nitrogen atom. The protons tell you. And the number of protons is the atomic number. And if you ever seen a periodic table which shows all the elements, the atomic numbers are basically the numbers of the protons. 1 is hydrogen, 2 is helium, and so forth. Now, in its neutral or normal state, the number of protons and electrons will be the same. If some of the electrons leave, it'll become more positive. Because some of the negativity is left. Get out of here, you negative people. But in its neutral state, you'll have the same amount of protons in the nucleus and the same amount of electrons swirling around in the cloud. An atom can gain or lose electrons and become positively or negatively charged ion. We call it an ion if some of the electrons leave. Now, it can also gain electrons and become more negative. Oh, I don't like being around you. You're too negative. So it becomes an ion if it becomes charged because of electrons either leaving or being gained. And I think that's about all we have in this video. This has been an introduction to electric charge as we start our path through electromagnetism. Oh, the process of becoming an ion is called ionization. There, now I'm done.